Welcome to the Deep Dive. This is where we take a whole stack of sources and research today. It's all focused on the insights from AI pioneer Andrew Ng, and we basically pull out the key knowledge you need fast.
Exactly. So you, the learner, can get up to speed on big topics without feeling, totally swamped.
Yeah, think of it like the highlights reel, but with real depth.
Right, the express route to those aha
Yeah.
moments.
And today we're laser focused on building a career in AI. We've really dug into Andrew Ng's simple guide to pull out the actionable steps and maybe some surprising perspectives on how to navigate this whole field.
It's such a hot topic. And N kicks things off with a really powerful quote, doesn't he, about AI being the new electricity.
He does. AI is the new electricity. It will transform and improve all areas of human life. That really sets the stage, I think. It shows why figuring out a career path here is, well, pretty important.
Absolutely. And he breaks down that path into essentially three big phases. First, you've got to learn the technical skills.
Yeah.
Second, you need to actually do stuff, work on projects.
Makes sense.
And third, there's the whole process of finding a job. So we're going to walk through each of those.
Perfect. Let's jump into that first stage then. Learning the technical side.
Oh.
Eng has this great analogy. Coding AI is the new literacy. What's behind that idea?
Well, it's kind of like looking back at history. When reading and writing weren't common skills.
Right.
As societies changed, being literate became fundamental. It empowered everyone. Eng sees coding, specifically AI coding, going down a similar path. It's becoming a basic skill for interacting with this tech.
So it's different from just general computer programming.
Exactly. Traditional software development is like giving the computer very specific step-by-step rules.
Okay.
But AI, machine learning, that's different. It's more about teaching computers to figure things out from data themselves. This AI literacy, as Eng calls it, is becoming super important as AI gets woven into everything.
He used that pizza maker example, which I admit initially I was like, how does that connect?
Right. It seems a bit random. If you're making pizzas, learning to build a video game might not feel relevant.
Yeah, exactly.
But Eng shows how AI and data skills bring real value, even in fields that don't seem techy. For the pizza guy, simple AI could help predict dough needs, staffing, even, how many pepperoni pizzas to prep.
Ah, okay. So it's about using data effectively.
Precisely. AI literacy unlocks those data-driven insights almost anywhere. That makes it a really valuable skill across the board.
So these AI-specific data skills might actually have a broader application than traditional coding down the line.
That's his argument, yeah, because data's everywhere. Being able to use AI to get insights from that data,
Yeah.
that's huge. Which brings us neatly back to step one, actually learning those foundational technical skills.
Okay, so what are the key skills and flags is most important? It feels like there's so much out there.
It can seem overwhelming for sure. He breaks it down into four main areas. First, foundational machine learning. The basics, yeah. Understanding models like linear and logistic regression, neural networks, decision trees, clustering, things like that. Plus, core concepts like bias versus variance, cost functions, optimization, error analysis. You need that grounding.
Right. What's next?
Second, deep learning. Given its impact, you need to get the basics of neural networks, how to tune them, hyperparameter tuning, convolutional nets for images, sequence models for like text or time data, and transformers.
Okay, that's already a fair bit. What else?
Third is software development. You can dabble in AI without being a coding whiz, but to build real systems and have more career options, you need solid software skills.
So programming fundamentals.
Yep. Programming fundamentals, data structures used in ML, like data frames, algorithms for handling data, good software design principles, definitely Python fluency, and familiarity with the big libraries like TensorFlow, PyTorch, scikit-learn.
Got it. And the fourth area, I think I know what's coming.
Math. Yeah, the math behind machine learning.
Always the big question. What kind of math are we talking?
Mainly linear algebra, vectors, matrices, all that. And probability and statistics, exploring data, understanding distributions, basic probability concepts. He also says an intuitive feel for basic calculus helps.
Intuitive, okay.
Yeah, but he makes an important point here. Things are changing. With software tools that handle a lot of the complex math automatically, like automatic differentiation, well, you don't need to be a calculus expert doing derivatives by hand quite as much as maybe you used to, especially for designing networks.
That's probably a relief for quite a few people listening.
Yeah.
But it's still, that's a lot of ground to cover. How does Neng suggest people actually approach learning all this?
He acknowledges it's a lot, absolutely.
Yeah.
He says prioritize Focus on the most critical stuff first, and he strongly recommends structured courses, at
Yeah.
least initially.
Rather than just random YouTube videos or blog posts.
Exactly. Good courses provide a logical flow, consistent language, they avoid repeating things unnecessarily, and cover the ground systematically. Less likely to have big gaps in your understanding. Once you've got that solid base, then dive into research papers, more niche topics.
Build the foundation first. Makes sense. And I guess with AI moving so fast, the learning probably never really stops.
Oh, definitely not. Eng is very clear. Anyone doing well in ML is a lifelong learner. You have to be. The field changes constantly. You've got to keep up.
So how do you build that habit? Does he have tips?
He does, yeah. He mentions BJ Fogg's tiny habits idea.
Tiny habits. Tell me more.
It's really simple but clever. Start ridiculously small, like super small. Focus on consistency. So instead of saying, I'll study AI for an hour every day, which is hard to stick to commit to something tiny, maybe watch just 10 seconds of an educational video daily.
10 seconds. Seriously.
Seriously. The goal isn't the initial learning in those 10 seconds, it's building the habit of doing it every day. You succeed at the tiny goal, feel good, and keep the streak going. And often, once you start, you'll naturally watch for longer anyway.
Huh. That actually sounds doable. Okay, let's circle back to math for a second. That big question. Should you learn math to get a job in AI? What's Eng's final word on that?
His view is very, very practical. He says, yeah, math is good to know, but prioritize based on what you actually need to do the work you want to do or make the decisions you need to make.
So it's not about learning math for math's sake, necessarily.
Not unless you want to. It's more about asking, what knowledge do I need to build this model? Or what do I need to understand to debug this system? Or even just, what math do I need to know for this job interview?
A very applied approach, then.
Totally. And he points out the level of math needed can shift. Like his linear algebra library example. Maybe years ago you needed a deeper understanding to use them safely, but now they're so robust, maybe a higher level grasp is fine for many tasks.
But there's still areas where deep math understanding is crucial,
Oh,
right?
for sure. Especially if you're pushing the boundaries in deep learning. If your optimization algorithm isn't working, understanding the math behind gradient descent or atom can be critical for debugging.
Right.
Or if your neural network is acting weirdly on certain inputs, knowing the math of the architecture might be the only way to figure out why.
Makes sense. And he does encourage learning, just out of curiosity too, doesn't he?
He does. If a math concept sparks your interest, dive in. Even if there's no immediate payoff. You never know where that curiosity might lead, maybe a new idea, maybe a breakthrough. And again, he stresses that things like automatic differentiation are changing the landscape, handling some of the heavy calculus lifting.
Okay, great. So we've covered learning, that foundational step. Now, the second phase, N outlines, working on projects. He says this is key for like making the skills stick, building a portfolio, and actually having an impact.
Exactly. But he also flags that AI projects have their own unique set of challenges.
Like what?
Well, for one, AI is still pretty new, relatively speaking.
Right.
Technologies change fast, so it's often really hard to estimate how long a project will take or what the exact return on investment will be.
Yeah, I could see that.
Plus, AI development is super iterative. You might not know upfront how long it'll take to get your model to the accuracy you need. That makes project management tricky. And then there's stuff like model drift, where performance degrades after you deploy it.
And I bet working with stakeholders who aren't AI experts adds another wrinkle.
Definitely. Explaining the nuances, setting realistic expectations, that's a common hurdle. Which is why Eng offers this really useful 5-step framework for scoping AI projects effectively.
Okay, a framework. Let's break that down. Step 1.
Step 1. Identify a business problem, not an AI problem. Talk to the domain experts. Ask them, what are your biggest headaches? What do you wish worked better? Why hasn't it been solved?
Find the real pain point first.
Exactly. His example is about climate change. Maybe you talk to power grid operators and find they struggle to predict renewable energy generation accurately. That's a real problem.
Okay, makes sense. Step 2.
Step 2. Brainstorm potential AI solutions. And don't just latch onto the first cool idea. Think broadly. For the power prediction problem, maybe satellite imagery helps map turbines, or weather data predicts cloud cover.
Consider multiple angles.
Right. And critically, sometimes you might realize, you know what? AI actually isn't the best solution here. And that's okay too.
Good point. All right, step 3.
Step 3. Define clear milestones. And this means both machine learning metrics, like accuracy, and business metrics, like revenue impact or user engagement.
So connect the tech to the business outcome.
Yes. because just improving test set accuracy doesn't always solve the business problem. Sometimes you need a quick proof of concept to help figure out realistic milestones too.
Okay. Step 4.
Assess feasibility and value. Is it technically doable? Look at research competitors, maybe build that quick prototype, and is it actually valuable? Go back to those domain experts, the grid operators in our example, and ask them about the potential benefits.
Check if it's possible and worth doing. Got it. And the final step, number 5.
Budget for resources. Everything you need. Data, people, time, integrations with other systems, ongoing support. If you need satellite images, what's the cost? And remember, it's iterative. If something isn't feasible, you might need to loop back to an earlier step.
It sounds like a really solid way to approach these often fuzzy AI projects. So, okay, we need projects, but how do we find ones that actually help our career grow beyond just being, responsible or ethical?
Yeah, that's crucial. Eng suggests thinking long-term. Your career will likely have many projects, hopefully getting bigger and more impactful over time. Start small, it's fine. Use early projects to learn.
Don't wait for the perfect, huge project to land in your lap.
Exactly. A lot of people start with personal projects, things they do in their spare time. Those small wins can open doors.
Does he give specific tips on generating project ideas?
He does. Several routes. 1. Join existing projects. See someone doing cool work. Ask to help. 2. Keep learning and talking to people. Read papers, take courses, chat with experts in different fields. That sparks ideas.
Yeah.
3. Look for areas where ML isn't widely used yet. He did this himself with autonomous helicopters and online ads back when they were novel applications. 4. Maybe develop a side hustle. Even if it's small, it gets you creating.
He also has a sort of checklist for picking projects, right? What do we look for?
Yeah, key questions are, will this project help me grow technically? Is it challenging but achievable? Do I have good teammates or at least people to bounce ideas off? Collaboration is key. And can this project be a stepping stone to something bigger later on?
Thinking strategically about where each project fits makes sense. He also talks about decision-making styles. Ready, aim, fire versus ready, fire, aim. How does that apply here?
It's about how you approach starting. Ready, aim, fire is the careful planning approach. Validate everything thoroughly before you commit resources and execute.
The traditional way, maybe?
Kind of. Ready, fire, aim is more. Jump in quicker. Start building, start executing, and figure things out. Adjust as you go. N leans towards ready, fire, aim for building ML models specifically.
Why is that?
Because iteration is often cheap and fast. You can build a basic model, see where it fails, analyze the errors, and improve it quickly. The cost of trying something isn't usually massive. But, he cautions, for really big, expensive, or irreversible decisions, that careful, ready, aim, fire approach is probably smarter.
Got it. Depends on the stakes. So you do these projects, you learn a ton. Now you need to show people. Let's talk portfolios. What
Wow.
makes a good AI portfolio?
Eng sees a natural progression. You start with class projects, usually well-defined, specific goals, good for learning basics.
Okay.
Then maybe personal projects applying skills to your interests, maybe trying to replicate a paper. Then you move to creating value for others, maybe a small tool at work, maybe a Kaggle competition.
Right.
And the goal is to show growth towards projects with bigger scope, more complexity, tackling harder problems, having more impact.
So even those really early, simple projects are important stepping stones.
Totally. He mentions one of his own early projects was just getting a neural net to mimic a sine wave. Not world-changing, but a crucial learning step. Showing that journey in your portfolio is really powerful.
And it's not just about the code, is it? Communication seems vital, too.
Hugely important. Eng stresses this. You need to explain your work, its value, your thought process. How else will people trust you with bigger projects or more resources? Good communication is key for moving up.
And leadership, too, even if you're not a manager.
Absolutely. On larger AI projects, your technical insights often drive the direction. That's a form of leadership, guiding the technical strategy, even without a formal title.
Okay, fantastic. We've learned, we've built projects. Now the third big step, finding a job. This can be the scariest part for many. Eng has a framework, especially for people switching fields into AI.
Yeah, and his advice here is really insightful. He suggests focusing on changing either your role or your industry first, but probably not both at the same time, right when you're starting in AI.
Ah, okay, so one change at a time.
Exactly. If you're, say, a finance analyst wanting to be an ML engineer, maybe first try finding a data science role within finance. Leverage your domain knowledge while you build AI skills. Or maybe become an analyst, but at a tech company. Use your analytical skills in a new industry where you'll get more exposure to AI. It makes the transition less abrupt.
That sounds much more manageable. He also mentioned startups might be good for this kind of switch. Why is that?
Startups often have, less rigid roles. Everyone wears multiple hats. If you're there and show you can help with AI stuff, even if it's not your main job, it's often noticed and valued. It can create a path to shift roles internally.
Interesting. Now, he really emphasizes something called informational interviews. What are those and why are they so useful?
An informational interview is basically just a chat. You reach out to someone in a role or company you're interested in, not to ask for a job, but just to learn about their work. It's best done before you're actively applying.
So low pressure, just gathering intel.
Exactly. And super valuable in AI because job titles are all over the place. What a machine learning engineer does at company A might be totally different from company B. These chats help you understand the day-to-day reality, the key skills, the team culture.
What kind of questions should you ask?
Things like, what's a typical week like? What are your main tasks? What skills really matter for success there? How does the team work together? What's the hiring process like? What makes someone stand out?
Getting the real story.
Right. Eng says, do your homework first, research the person, the company, so you ask smart questions. And he encourages building your network this way and also paying it forward later by doing these for others.
That's great advice. Beyond informational interviews, what about the core job search stuff? Resumes, interviews.
He stresses the fundamentals, naturally. A compelling resume, a strong project portfolio, good interview performance. Tailor your communication to each company. Research what they value. Practice answering questions. Brush up on skills. Take notes.
Standard good practice, really.
Pretty much. He also advocates for being respectful and aiming for win-win situations during negotiations.
And he puts a lot of emphasis on the team you join, doesn't he?
He really does. He says the people you work with are as important as the project itself for your growth and happiness. He encourages you to really try and talk to potential teammates before accepting an offer, even if it's sometimes tricky logistically. Find that good fit.
Good point. And leverage your network, too, right? For advice, maybe referrals.
Absolutely. Use your community and approach the whole search step by step. Start with research, do those informational interviews first. Don't jump straight to applying everywhere.
Okay, so landing the job is one thing, but building a long-term career is another. N touches on other key elements for success beyond just getting hired.
Yeah, several important ones. Teamwork is huge. Collaboration, communication, critical for complex AI work. Networking, but he frames it more as building genuine communities, not just transactional contacts, which is great for introverts too. He also gives a reality check on the job search. It's one part of a long career. Don't get swept up in bad online advice. Personal discipline across life helps professional success. And interestingly, altruism helping others often benefits you too.
That's a nice perspective. He also tackles something really common, especially for newcomers: imposter syndrome. What's his advice there?
First off, he normalizes it, says it happens to everyone, even experienced people. He shares his own struggles early on. His main message is, the first step to getting good is often, well, sucking at it for a bit.
Okay, fair enough.
And crucially, if you want to be part of the AI community, you belong, full stop. To combat the feeling, find supportive mentors or peers, actively recognize your own strengths, and this is key, help people who are just starting out behind you.
Teaching reinforces your own knowledge.
Exactly, and it builds your confidence and sense of belonging.
That's a really positive and inclusive message.
Yeah.
So as we kind of draw towards the end, Eng offers some final thoughts about making every day count.
Yeah, he gets a bit more reflective, talks about thinking about time passing each birthday, and then he asks this really simple but powerful question about how many days are in a typical human lifespan. He wants you, the listener, to just pause and think about your gut reaction, no calculators allowed yet.
It does make you pause, doesn't it?
It really does. He shares that when he was a grad student, he actually calculated his estimated remaining days and was just struck by how finite it felt. He even printed the number out as a daily reminder.
Well,
And he leaves us with this final thought to mull over. Whatever you're doing today, is it worth roughly 130,000 of your life, assuming a lifespan around that many days?
that definitely puts things in perspective. So as you're listening and thinking about all these insights from Andrew Ng, maybe consider what's that next small step you can take, whether it's in your learning, your projects, or just exploring this field.
Yeah, and remember, AI is this huge, constantly changing field. There's so much potential, and your unique perspective, your skills, they can absolutely play a part in shaping where it goes next.